So this is the first problem of the contest, thala for a reason. In this problem, we just have to we have to take an integer as input and print thala in case if n is equal to 7, otherwise print sach. So basically, we just have to take input and give some output. This is pretty simple. Everyone would have done it. Let's see the second problem. The second problem says that we are being given a positive integer n, and in one operation we can either subtract 3 or subtract 4 from n, and we have to tell if it is possible to make n equal to 0 by performing some operations. So we are being given some integer n which is gonna be positive. It would have been mentioned here in constraints. So n is greater than equal to 1, and what we can do is either subtract 3 from n or subtract 4 from n, right? And what we want to do is make n equal to 0. We have to tell if it is possible to make it equal to 0 after performing some operations of either of these a few times or any number of times, right? This is the problem. So you can just try out a few, like maybe just the simple test cases, because in simple problems it is really easy to just try out a few test cases and figure out some pattern. So if you have n equal to 1, it's obvious it's not possible because you cannot make it equal to 0 by performing any of these operations. Not possible. If n is equal to 2, again not possible. If n is equal to 3 or 4, in both these cases it is just possible. You can subtract either 3 or 4 from it and make it equal to 0. For n equal to 5, it is not possible. If you check for n equal to 6, it is possible. You can just have subtract 3 twice, right? For 7, you can just call it as 3 plus 4. It is possible. For n equal to 8, you can call it as 4 plus 4. It is possible. For n equal to 9, you can call it as 3 plus 3 plus 3. Again possible, like subtract 3 thrice from 9. For n equal to 10, instead of having a 3, just take a 4. So again, it is possible. For n equal to 11, instead of taking a 3, just take up a 4. So yeah, again, it is possible. And here you can just see the pattern that every time you will just, instead of taking a 3, you will take a 4. And if you have all the 4s, like for n equal to 12, you have all 4s, it is possible. After that, instead of taking 2 4s, you can just take 3 3s for the next element. So every time for all the numbers after this, it would be possible, right? Um, it is, I think, now like obvious if you have tried it in this way, it is clear that if n is equal to or greater than 6, for all of them, you are just getting a yes. If n is equal to 3 or 4, it is possible. And for n equal to 1 or 2 or 5, in these cases, it is not possible, right? Yeah, some people have written the solution here. For 6, how is it possible? Like for 6, you can just say subtract 3 twice. 6 is nothing but 3 plus 3, right? Okay, so this problem is also, I think, would have been done by everyone. So DP is not required here. Like DP is just overkilling the problem. It is something you can just have it with observation. This was nothing but observation here. You tried it for a few cases yourself and then noticed a pattern that after 9 10 at this place you would have observed it is always going to be possible for any greater value of n. Okay, so should we move on to the next problem after looking at code? The code is also very simple, just if else conditions. For every test case, just check if n is less than equal to 2, basically just 1 or 2, or it is equal to 5. In that case, the answer is no. Otherwise, for all the other cases, it is yes. Simple. Okay, so let's see the next problem then. The next problem is If it is a multiple of 3 or multiple of 4, then possible. Yeah, obviously it is possible. If n is a multiple of 3, then just subtract 3 from it x times, it would become equal to 0. But it's not required. Yeah, someone said this, that it's not required to check that thing. Okay, this is the third problem, maximum score. In this problem, we have been given a binary array A of even length, and initially our score is 0. We have to perform an operation n by 2 times, in which we just select an index and add the modulus of ai minus ai plus 1 to score, and delete these two elements from the array without changing the order of the other elements. And after this, the length of the array would be decreased by 2 because we deleted two elements. And we have to find the maximum score which we can get if we perform the operations optimally. So, yes, Codechef publish editorials. You can check this on discuss.codechef.com. I think that someone would have even made up a small video on YouTube to tell how to watch editorials on Codechef. Okay, let's come back to the problem. We have been given an array. We have been given an array of size n, which contains um, some zeros or ones, some zeros or ones. And what we can do is in one operation, just choose an index, I, which is greater than equal to 1 and less than n for one based indexing. And now delete ai and ai plus 1 from the array, and add, or maybe call it as this, that first of all add ai minus absolute difference of ai and ai plus 1 from the array to our answer or our score, better call it as score, and delete ai and ai plus 1 from array. After this, the length of the array will be decreased by 2. Right. Right. I hope that the operation is clear, that in one operation, we are just choosing an index like other than the last index. And this n is nothing but the length of the array at the time when we are applying the operation. We will just add the absolute difference of that index and the index just after it to our score, and delete ai and ai plus 1 from the array. Right. Just say yes in the chat if the operation is clear, the operation which we are performing. So here you can observe one thing. If ai and ai plus 1 are equal, then performing operation is not really increasing my score. Then performing operation is not increasing my score. Right. Yeah, I will explain with an example also. The thing which I wanted to here notice is when you are choosing an index, let's say you have, let's say you're having an array 1011, 1011, and you choose this index. This is I, so this will be I plus 1. Basically, we are just choosing two consecutive elements. We will add their absolute difference, add the absolute difference of the two elements to our score, and delete these two elements from the array. Delete these two from array. So array will become equal to like 1 1 only once these two would be removed from the array. This is what happens in one operation. So if the two elements which I am having are equal, let's say if the two elements are 1 1, then absolute of 1 minus 1 would be just 0. So I won't have any increase in my score. I would just lose two elements, right? So if I have something like 1011, is it good for me to choose something like this? Or should I always choose a 1 and a 0 in an operation if I have at least 1 0 and 1 1? Right? Like, just try to think about it. If I have a 1 in the array and a 0 in the array, should I choose these two together, or should I choose any two equal elements at that time? The answer is obvious that choosing this kind of thing is gonna be better. Let's take an example. If you have the array as 0011, if you have the array as 0011 and you choose two equal elements, then the array will become only 1 1, where you don't really now have any choice and you will choose these. The array will become empty and you got no increase in score, right? Here you got the score equal to 0. But if you had chosen 0 1, in that case, the array would have become 0 1 and you would have got a score of 1 here. Again, you choose 0 1 and you get the array as empty and you got a score of 1 again. So basically, we have observed one thing here. If you have a 0 and 1 at adjacent to each other, just apply operation on these. Just apply operation on these and you will get the score incremented by 1, because absolute difference of 0 and 1 is just 1, right? Can I say this? In case if anybody has any doubt at this part, please ask it in chat. I will be waiting for half a minute. Let me just find. Yeah, Dhruv, you have what you have written is some the thing which we would be doing afterwards. But I'm asking that, is there anybody who has any doubt in this part till now? Okay, someone wants me to repeat it once again. Okay. So the thing is, we have been given a binary array which contains either 0 or 1. Every element in the array would be either 1 or 0. In one operation from the array, let's say it is 1011, we just choose two adjacent elements, any two adjacent elements, add their absolute difference, which in this case would be 0 minus 1, which is just 1, to the score. You have a score variable which is initially 0. You will just increment absolute difference into the score and delete those elements from the array. So the array will become here 1 1. This is something you do in one operation. So here we just wanted to see that, should I ever apply an operation on two equal elements? If I can apply an operation on two unequal elements also. The answer, the conclusion which we have got is, applying an operation on two different elements is just better, because it is giving me a score of 1 and there is no problem in it. If I apply an operation on two equal elements, I will not get any score, and in some case it might be bad for me. Like in case of 0011, if I apply an operation on 1 1, I will just get my array converted to 0 0. I didn't get any score here. So eventually it is just doing bad for me, right? So here now we have understood that whatever the count of 0 and 1 we have, after every operation which we perform, if both the counts are greater than 0, they would just get decremented by 1, because we are having 1 0 and 1 1 being removed in one operation, right? If we are having more than 0 zeros and more than 0 ones, and we are getting something like 1 0 being removed from the array in the operation, then the count of 0 would be decreased and the count of 1 would be decreased. So how many times can you apply the operation? Just try to think of how many times can you apply the operation until any one of them becomes zero. Just try to think of it. You will realize that it is nothing but you can just apply the operation minimum of CNT0, CNT1 number of times. You can apply the operation minimum of this number of times. And this is our answer. Once you get any one of the frequencies of 0 or 1 equal to 0, after that, whatever you do, you will not get any increment in the score. So the score, maximum score you can get is equal to the minimum of count of 0 and count of 1. So should we move on to the next problem? Like look at the code and move on to the next problem? Or does anybody have any doubt in this problem? I guess nobody will have any doubt, at least for now. Can we take a DQ and always take the first two elements and after calculating score pop the first two elements? No, like using a DQ will just complicate the things. Like eventually you would be doing only this part for getting the answer. So using DQ is bad, like useless. Yeah, you can use a stack also, but using a stack is also just eventually going to give you the same answer, and it is just overcomplicating the thing. Okay, let's see the code. In the code, what we do is take up the inputs, and while taking the inputs, just find the count of both zeros and ones and print the minimum one of them. Simple. Only this much. Let's see the next problem then. Let's see the fourth problem. In the fourth problem, we are being given an array consisting of n elements. All the elements are positive, and we have to check whether it is possible to whether there exist four distinct indices I, J, K, and L, such that if the indices are I less than J less than K less than L, then AI plus AJ is not equal to AJ plus, oh sorry, AK plus AL. Basically, in simple words, in very simple words, the problem says you are being given an array, it and they are asking whether it is possible to choose four distinct indices in the array, and the sum of the first like elements on the first two indices is not equal to the sum of elements on the last two indices. This is the problem. Let's take an example. If the array is 1 2 3 4, let's say it is 1 2 3 4 5. Is it possible to choose four distinct elements and have the sum of first two not equal to the sum of last two elements which you chose? Here it is possible, you just choose 4 and 5 and 1 and 2, right? In this case. And like in the case where you have 3 4 2 5, you don't really have any choice here. You have only four elements, so you have to choose on all four of them. The sum of the first two is equal to 7, and the sum of the last two is also equal to 7, which are equal. So these four elements would not be good, and you don't really have any other choice. So basically, you cannot have four elements where the sum of first two is not equal to the last two. The answer would be no here. Right. Please say yes or no in the chat whether the problem is clear or not. So let's look at the very obvious things here. From the test cases itself, we would just look at the test cases and try to think of what the things we can do. What are the things which we can do? If n is equal to 4, which we can see from the first test case itself, we don't really get any choice. We just have to check if a0 plus a1 is not equal to a2 plus a3 or not. Like if it is equal or not. If it is equal, then print no. If it is not equal, then print yes. Right? We don't really have any other choice. We can't do anything. If all elements, if all elements of the array are equal, like now we are talking about the cases with any n greater than 4 only. If n is equal to 4, then we don't have any choice. Only when n is greater than 4, we are checking about if we can do anything else or not. So if all the elements of the array are equal, then answer is no, right? If all the elements of the array are equal, so whatever 4 elements you choose, the sum of the first two would be equal to the last two because all elements are equal. And if the array contains only equal elements, whatever 4 elements you choose, all these 4 are gonna be equal. Let's say it is x, so x plus x would definitely be equal to x plus x, right? So that's why the answer is no. At any point, if anybody has any doubt, then feel free to ask it in the chat. Now, for the case when n is greater than 4 and there are like all elements are not equal, all elements are not equal. Try to think if we can actually just take out 4 elements every time or not. So if the array is this, if you have an array with any elements, but all the elements are not equal, just imagine you compare the first two and the last two elements of the array. You compare a0 plus a1 equal to a n minus 1 plus a n minus 2. Yeah, something like that can be do. And then basically just check out the first two and the last two elements. In case if the sum of the first two is equal to the sum of the last two, then what you can do here is just choose any other element in the array which is not equal to any one of these, like any of these. Maybe you can have something like 1 1 2 1, and the element you choose is 1. Other element you choose, sorry, maybe something like 1 2 2 1, है ना, where the elements are initially equal. You just find out any other element in the remaining array which is not equal to any one of these elements, and just instead of picking up this guy, pick up this guy. Now the sum of the RHS would differ. The sum of RHS will become different, right? Sum of RHS will become different for sure. This is definitely going to happen because we have just changed an element from RHS, and initially the LHS was equal, but now it would be different because RHS is changed. Now for some people it might not be very clear if you're not able to visualize this thing. So for them, I'm going to take up an example. Just imagine something like if the array is 1 2 3 2 1, anything it, or maybe let's have it a little bit more generalized. You have 1 2 some elements, then something like 1 2 3, then some more elements, and at last you are having 1 2, and you just chose the first two and the last two elements. Their sum is equal. So now what I'm saying is, from the array, from the remaining n minus 4 elements in the array, just choose any element which is not equal to um, any of them. Let's say I choose this one which is not equal to this two and this two, and instead of this two just pick up this one, or instead of this two just pick up this one. So what will happen is, uh, you can just change the sum of LHS or RHS like this. Any one of them you change it, and now LHS and RHS would not have the same sum, right? Please say yes or no for the people who understood this and for the people who didn't understand this. So basically, we are just choosing first two and last two elements. In case if the sum is equal, just replace any one of the elements on the LHS or RHS with a different element. You will always have some different element in the array. If you don't believe this part, that we will always have some different element in the array from these. Try to think of an array in which you can't replace any one of the LHS or RHS element. If you try to create such an array in which you cannot replace the element, you will realize at the end that all the elements in the array must be equal. Okay, so someone gave one more test case. What if we have 1, 2, then some ones, and a lot of ones, and at last 1, 2? So the basic thing is, if you just talk about choosing first two elements, you can replace this two by any of the ones, or this two with any of the ones, or basically just in some very simple words, just think, if you have even one different element in the array and all the other elements are same, just choose this on either of the LHS or RHS and have all the elements equal. So if you are having an array like x, 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 some y, then some x's, just choose up this y and all the other x. You will definitely have a different sum, right? So should we move on to the next problem, or anybody having any doubt? And the thing which I was discussing earlier of replacing the element with some other element, this is actually a very useful technique, or maybe not a technique but a mindset, useful mindset. So if you didn't feel it very comfortable right now, try to think a lot about this because it is a very useful thing, and the more you think about it on your own, you will be more comfortable with it. Okay, so guys, please tell whether to move to the next problem or not. Only one guy has responded. Okay, great. So we can see the next problem. Or before that, let's look at the code. It is nothing but some if-else conditions. After taking the inputs, like right now, I'm talking about a specific test case. Like for every test case, I'm calling the function solve. In the test case, in the function, I'm taking the inputs first, then saying that in case if I have n equal to 4, I don't have any choice. I have to pick up the uh, 4 elements given to me only. I can pick up only these elements. If the sum is equal, print no, otherwise print yes. In case if n was not equal to 4, only then we would be coming to this line. We will say just find out whether all the elements in the array are equal or not. If all the elements are equal, print no, otherwise print yes. Why print yes? We have talked a little bit about it. I have not given any concrete proof, and you generally don't prove it mathematically. You just prove it logically in your brain during the contest. So let's see the next problem. Minimize maximum sub array sum. This is the fifth problem. In this problem, we have been given two integers x and y. It tells us that we have to consider an array A consisting of x occurrences of 1 and y occurrences of -2. We have to rearrange the elements in any order, and what we want is that the rearrangement of the elements not visible, problem E. Okay. Was my screen freezed? Okay, it was a problem with you only. Fine. We have to rearrange the elements in a way that the maximum subarray sum of like the maximum sum of any subarray of A should be minimized. Find the maximum subarray sum of such rearrangement of A. So first of all, let's talk about, if you have an array A, we call maximum subarray sum as equal to the sum, like the maximum of sum of all subarrays. Sum of all subarrays. Basically, all the subarrays which we have in the array, the maximum one of them is known as the maximum subarray sum. We have been given two integers x and y. We have to consider an array A of size x plus y, which has x occurrences of 1 and y occurrences of -2. And what we want is the maximum subarray sum of A should be minimized. So you don't want to have, um, let me talk about maximum subarray sum once. If you have something like if you have an array like 2, -3, 1, -4, 5. If you have an array like this, here the maximum subarray sum would be something like this 5 plus 3 thing. This subarray, it will have a sum of, sorry, sorry. Here the maximum subarray sum would be nothing but 5. Let's take this example. If you have a subarray like, if you have an array like this, 2, 3, -5, 2, -3, 5, -4, and 5. Here the maximum subarray sum would be the sum of these elements, which is 6. 10 minus 4, that is 6. Right? This would be the maximum subarray sum. If you had something like 1, 1, -2, 1, 1, 1, 1, 1, -2, -2, and then 1, 1, 1, something like this, where we are having two ones, then five ones, then five ones, and two negative twos in between. Here the maximum subarray sum, like again, it would be just in this part, right? Here we are having the value of x equal to 12. We are having 12x, and y is 3. We are having 3 occurrences of -2 in the array. So this is one way of rearranging the elements in which the maximum subarray sum is coming to be 12. Sorry, it is coming up to be 6, right? And I think it might not work here, but one of the rearrangements, the answer would still be the same actually, even in the other rearrangement. Let's talk. Let's take some other example for this. If you have, let's say, x equal to 6 and y equal to 5, or maybe just take x equal to 3 and y equal to 2. In this case, one of the rearrangements can be 1, 1, -2, and 1, right? This can be one of the rearrangements. And one of the rearrangements can be 1, -2, 1, -2, and 1, right? Which one do you think is better? In which one of them the maximum subarray sum is minimized? Yeah, right? In this one, the maximum subarray sum is minimized. Here you are having two ones together. This is just gonna be the maximum subarray sum 2. Here you are having no, like only ones coming one by one. So the maximum subarray sum is just 1. If you try to merge, if you have tried to have some this kind of subarray, the sum would just decrease, right? And you can try to think of some more uh, more arrays, some more rearrangements of examples. You will realize one thing, that if you want to have, if you want to minimize, minimize maximum subarray sum, then it is better, to keep ones separated with twos, separated by twos, or separated by -2s. If you keep some ones together, even, and don't keep ones here, then in that case you might have some subarray, like some maximum subarray sum to be larger. But if you keep ones divided by twos or partitioned by twos, whatever you say, like 2 minus 2 is acting as a wall here. In this kind of case, you will have the maximum sum to be reduced. You can just try to take up some more examples for making you satisfied for this. So, right. So now, if I have y number of minus 2's, can I say that I just place the minus 2's first? And then in the uh, like the dash which I'm using here, at these spots, I can start placing ones. Like I placed one here, then one, then one, then one, then one, then one, and so on. So that I would have uh, the minimum amount of one at any specific block as much as possible. Right. I don't want to have too many ones at the same block, and I want to keep them uniformly distributed. Does this make sense? Just write it in chat, yes or no. Does this thing make sense? That having such kind of an arrangement is going to benefit me. Now, if you want, you can try to think about a little more about this kind of an arrangement. That if you have, um, let's say, all the arrangements having 2 to 1s, all the blocks having right now, I'm going to refer these as blocks. The numbers coming between minus 2's as blocks. So if you're having 2 to 1s in all the blocks, where should I place the next one? Should I place it um, should I place it here or here or here or here or here? You can try to think about it. Yeah, the answer is anywhere. It doesn't really matter wherever you place it. As long as you have been distributing the elements properly, the next element, the extra element which you have to place, you can place it anywhere. It doesn't matter if I place it here or it would not matter. You can try this out. So the next thing which you would think now is like you know about x, you know about y, you know how to rearrange the elements. You are having some minus 2's, and between them you are having some blocks of 1s. Do you agree if x is not divisible by y plus 1? Like these are y plus 1 blocks. I'm having y plus 1 blocks right now. Let's reduce the value of y. If y is 3, I have 4 blocks. Let's say if x is equal to 8, in that case, I will have 2 to 1s in all the blocks. But if x is not divisible by y plus 1, in that case, some blocks will having, let's say I have x equal to 9, then some blocks will have one extra, well, one in them as compared to some other blocks, right? Try to think about it. It is also valid. So let me refer to this with mx, the maximum number of ones I'm having in a block, and let me refer to this as mn, right? So in this case, can I say that mx minus mn would either be equal to 0 or 1? In case if x is divisible by y plus 1, that is the number of blocks, then it would be 0, otherwise it would be 1, right? By the way, we are placing the elements in this way. If I have these 4 blocks, or yeah, if I have these 4 blocks, then I'm going to place a 1 in one of the blocks. Now, this block is having 1, 1, and this block is having, let's say, 0. Then I will place it here, then here, then here. Once all the blocks will have 1, 1, then I will start placing in them again. So basically, mn minus mx would always be 0 or 1. I can find mx by saying x divided by y plus 1 seal, and mn equal to x by y plus 1 floor, right? Now, though actually this doesn't really have to do a lot with the solution doesn't really require all these things, but Once you are placing the elements in this way, you should know about these things. That's why I'm discussing it. Now what? Just try to think of a case if the mx, the value of mx is equal to 1. Just think about the case when mx is 1. It means that the blocks between minus 2's, none of them has more than one. Some of them might have a 1, some of them might not have any of them, right? Like this kind of a case. So here, this one, like I can have the maximum subarray sum as to be 1. But if I try to have any larger subarray which includes any minus 2, then basically this one is definitely going to have a larger maximum subarray sum than this one. This is the thing I want to claim here. Here is a claim that if this subarray sum is this subarray is having a sum of 1, and I try to have a larger subarray, the subarray sum will never increase. Some might decrease, might not decrease, but like in case of mx equal to 1, it will decrease only. Some will decrease. Does this make sense? It is going to decrease because I'm getting a minus 2 in between, and whatever in this block I'm going to get at most one only, one occurrence of 1. So the sum is definitely going to decrease. Yes or no? Similarly, just assume if mn is greater than or equal to 2. In that case, again, I'm having some blocks of ones. It might have mx number of ones, or it might have mn number of ones. Then I have a minus 2, then again some ones, then minus 2, then again some ones. Now, my claim is the whole array will have the maximum sum. The maximum sum of the subarray would be the whole array. Why? Because just assume, like just try to prove it. Just assume if you consider this as the subarray with the maximum sum. Whatever sum it has, this subarray will either have a larger sum or equal to that, because this block would have at least two ones, right? Mn is greater than equal to 0. So including other blocks is just going to increase your sum or keep it same, right? So the two observations which I have made here is, in case if mn is greater than equal to 2, then take whole subarray. Okay, how increase? Just imagine if this block was having 3 ones, this block was having 3 ones, this block was having 3 ones. Right now, this block has only a sum of 3. If you take the whole big subarray, then it will have 3 minus 2, and here are 3. So the, like you just included this part minus 2 and a block. You just included a block and a minus 2. The block is going to have a sum of either mn or mx. If mn is greater than equal to 2, the sum of block will definitely be greater than equal to 2 at least. So it is never going to decrease your sum. It might increase, it might not increase, right? So in case if mn is greater than equal to 2, then answer is simply x minus 2 into y. You just take up the whole subarray. You have x occurrences of 1 and y occurrences of minus 2. Binary search on this, like binary search, I don't think it makes the problem easy. Kadani's algorithm cannot be applied here. Like if you had only one test case, what you could have done here is just say, I will be going to arrange the elements in this fashion as we discussed, in such a fashion, and then apply Kadani's algorithm. But Kadani's algorithm will take big O of n time per test case and the value of, sorry, big O of x plus y per test case. X and y are pretty huge, so it would just give you a TLE. In case if mx is less than equal to 2. If it is 1, we have seen that we can only pick up one element. And in case if mx is 2, you have some block, then a -1, then some block, then some -2, then some block, right? You have such thing. So if you consider this as a block, you will have some sum. Let's say the sum is this. If you include this, okay, I should use a pen here. Just imagine if you have a block of some ones, then you have, if you have a block of some ones, then you have a -2, then again you have a block, then again you have a -2, then again you have a block. So in this kind of a case, just imagine if this block is having a sum of S0, then if you include any other block on the other side, you will get a sum of, this might be mx, this might be mn, which means that it will be less than equal to 2. You got a -2 and s0. So this new thing which you added might be less than 0 also, but it would never be greater than 0. It would be at max 0 in case if the block had two ones, right? So this is what we can do in this problem. In case if mn is greater than equal to 2, then just take the whole array. If mx is less than equal to 2, then just take that one block. Now for the case when mx is greater than 2, you will see if mx is greater than 2, mn would definitely be greater than equal to mx minus 1. Like this thing is always going to be true. Like mn can be either great equal to mx or equal to mx minus 1. So mn would definitely be greater than equal to 2, right? And this case we have already written. Similarly, basically we have covered all the cases here, right? So please write yes or no in the chat if the things make sense or not. And I want yes or no from everyone. There are 20 people in meet. Not whole array given max, but some of the array given maximum, including one or more -2 in between. Yeah, like for that part only we discussed this thing, that in case if mx is negative, like 0 or like 1 or 2, if the value of mx is 1 or 2, in that case, whatever the one of the blocks is giving you as the answer, like the block with the maximum is giving you as the answer, including any other block is not going to increase the score. So it is never gonna be possible that it give you better sum. And for the case when mn is greater than equal to 2, if you have some ones, then a -2, then some ones, then a -2, and then again some ones. In this case, if you say that the sum of the number of ones in this block is as 0, taking up another block is either gonna be increasing the sum or it would keep it same, because even in the worst case, this block is having two ones. And if you get a -2 also, then again you got nothing, you lost nothing. But if this block had three ones, then you will get something. So eventually you would just take the whole array in this case. Take the whole
I
array.
was saying, can we apply binary search here for every partition? Like, because
Um,
it is a predicate monotonic function.
how will you
That's why.
create a how will you create that predicate monotonic function there? Like how will you
Because
verify? If I
because
say,
we have by plus partitions, and like we can check for any mid part that maximum x can be put here or not.
like if I ask you that tell me whether it is possible to have a sum of k with the partition or not, how will you do it? To
So like
me,
we
no
maximum by
simple thing
partitions,
is coming.
and
To my mind, no simple case is coming right now. And I think that even if you apply binary search at under the hood, you would be using something like this in inside it, like some version of these observations only. Um,
Okay.
yeah, like this is something which is coming to my mind. Though I might be missing something at the moment.
Actually, I put my code in comment. So,
Okay, and max is equal to mid into pause. If max is greater than equal to x, what is this x?
but there's one condition more. We can take whole array as the maximum. Otherwise, this condition will work.
Um, check mid of y plus 1. I would look at it after the session, I guess.
Okay.
After the session, you can remind me. I would look at
Okay.
it.
Yes.
Yeah. But at the very least, this approach is gonna be easier one. So I like try to be comfortable with this mindset also. The way of thinking. So from this problem, what we learned is we wanted to have minimum subarism. We would for that we realized that having more ones together is worse with uh, some examples. Like one of the examples I showed, I think I removed it. One of the examples I showed is this, that having more ones together can be problematic. It might increase the maximum sagarism. Having them distributed uniformly is better. And from there, we just try to uniformly distribute it. And what I mean by uniformly distributing it is, let's say you have, let's say you have five post office and you have to post seven letters. So posting letters in a way that the difference between the post office with the maximum letters and the um, something like this, where the difference between the maximum letters and the minimum letters is minimized, which is like either one or zero, and something like this is bad. Here, this post office will have a lot of work and this will have very less work. So we want to have something uniform like this. One simple thing you can do is just increase give one post once, then increase it by one until you post seven letters, right? Okay, after that, after posting them, we did this kind of case work, that if you are considering one block, should you consider another block or not? For that, we just like when you try random stuff, you would just come across this, that if this block can have either one or two ones, then it is never good for me to just get a -2 and then have one or two ones there. So this was one of the cases, and the other case was that if I know the block will have at least, if the block will have at least two ones, then it is always beneficial for me to just include it, because I will at the very least not have any problems there. Okay, so let's the code. Here, instead of writing y plus 1 again and again, I just took y1 equal to y plus 1. Then for finding the upper seal, like the seal of x by y plus 1, we, if you want to find, let's say you want to find a by b sealed, maybe 17 by 10 as 2. So for that, what we generally do is add 17 plus whatever is in the remainder minus 1 and just normally divide it by that. In C++, it automatically takes the floor division. So you will get 2 here like this. So instead of writing a, for writing a by b seal, we write a plus b minus 1 by b. That's what we are doing here. For dividing x into y plus 1 parts. First of all, I'm saying y1 for y plus 1. So for dividing x into y1 parts, I'm saying x plus y1 minus 1 divided by y1. So now I got what would be the maximum number of ones in any of the blocks. And you could find n also, but in the answer, I'm not really using mn anywhere, so I removed that line. In case if mx is less than equal to 2, then in that case you will have just answer as mx. In case if mx is greater than 2, then mn would be less greater than equal to 2. So we will just print out this case that maximum of x. Yeah. This maximum part is also something you don't need to write, I guess. If you write like this, it should also work. But just to be on the safer side, I wrote it like this. Yeah, I think with now we can go a little fast. For the basic problems, I did want to spend some more time so that even if someone doesn't know a lot, should be able to understand. Okay, let's move on to the next problem. Now, for the people who are coming till this problem, they would already be quite experienced, so we can cover them a little fast. The problem is make all equal. In the problem, we have been given an array of n elements and a positive integer m such that 1 is less than equal to ai is less than equal to n. We can perform the following operations on a. Select at most m elements on a and increase all of the selected elements by 1. Find the minimum number of operations required to make all elements of a equal. It can be like this as just raised to line. So we are being given an array a of n elements. All the elements are positive. I think it has mentioned. Yeah, all the elements are positive and less than equal to n. And in one operation, what I can do is choose m elements, and increase them by 1. Increase them by 1. And I want to make all elements equal. I want to make all elements equal. So what we can do here is, since we have to make all the elements equal in minimum operations, in minimum number of operations. Let's say if the array is something like 1, 2, 3, 4. 1, 2, 3, 4. And let's say 5 also. What should I do here? Imagine m is 1. One thing which makes sense for me right now is I want to make all the elements equal to 5 here. It would take me the minimum number of operations because I cannot make this 5 smaller. In the operations, I can just make elements larger. So making all the elements equal to 5 is something I can do, and it would take me some operations like 4 operations required for 1 to become 5, 3 operations for 2 to 5, 2 operations for 3 to 5, and 1 operation for 4 becoming 5, 0 operations required for 5 becoming 5. Right. I can do this. In case if I wanted to make all the elements equal to 6, it would just redundantly increase all the number of operations by 1. All the number of operations would just become increased by 1. Like it would become 5, 4, 3, 2, 1. So it is not good. It is not good. And we will just make all the elements equal to the largest element here. Right. This is the first observation. Make all elements equal to the maximum number in the array. I'm denoting the maximum number in array as mx. I can just find out the number of increases in elements. Let's say sub operation. Like in one operation, I'm choosing m elements and increasing them by 1. Let me use the word sub operation for increasing an element by 1. So in one operation, I am performing m number of sub operations. Okay. I'm just using a word sub operation for now. You can choose, you can use any other word, any other word also. So I can find the number required number of sub operations. I can just very easily find the required number of sub operations. How will I find it? for every element, I can just say mx minus ai. This is the number of sub operations I need to apply on the current element. And for just summing up it for all the elements will give me the number of required elements I need. Or maybe you can just say mx into n minus the sum of all elements. This is also a way for finding it, for finding the number of sub operations I require. Okay, fine till now. Everything is simple. We have not discussed any hard stuff till now. Great. I can handle m sub operations, like at most m sub operations in one operation, right? I need, let's say, it to be x number of sub operations I require. So it would take me at least x seal division of m number of operations. It would take me at least this many number of operations to make all the elements equal to mx, right? This is the at least part, at least this many. When can you think of a case where it might cost me more than x seal division of m number of operations? I can help you with it. Let's say if the array is 1 3, m is equal to 2. Yeah, if I have to apply more than one operation, like if I have to apply a lot of operations on one number, I might in some case require more than this many operations. So a case like this, I have to apply two operations. The number of sub operations is 2, m is 2. So x by m, like x and m both are 2, so it should be 1. But here I require two number of operations because I choose this element 1, and again I choose this element, this very same element. So I require two operations here. So one of the things I can say as the minimum is this part, and the another thing I can say as the minimum is the difference between minimum and the maximum element, the maximum minus minimum element. This is also something I require at least this many operations, right? At least this, at least this. So how many operations do I require? I require at least the maximum of these operations, at least the maximum of x by m. The seal division of x by m is nothing but x plus m minus 1 by m, and mx minus mn. I require at least these many operations, and it can be proved, like the proof might become a little complex, but it can be proved that these many operations are always enough. These are always enough. And like you can just try to dry run it. Need proof got we. I don't understand what you want to say. Like the proof will just become complicated. Like mathematical proof is just not required. Mathematical proof, you never require this. Almost never. You almost never prove it because solving a problem might take only 5 minutes, but mathematical proving might take 15 minutes of yours, or maybe another 5 minutes, which is just a waste of time. You can logically prove it in your head, but the thing is, in every operation you make, if you have an array like 1 2 3 4 5 and m is equal to 4, every time you make up a move you will make it on different elements, and you will try to have the maximum number of sub operations you can perform on every element. So let's say you apply sub, you have m equal to 4 and you apply 4 sub operations. After this the array become 2 3 4 5 5. Now you applied operation on these elements. So now you applied it on three sub operations. Like now you got three sub operations. Then you have 3 4 5 5 5. Like basically you just have two and then one. If you are just having the maximum number of sub operations you can perform every time, and like in that case, you are basically just doing the best thing you can do. We are not doing any bad stuff right now, and it will take you at least mx minus mn also. Yeah, basically, I'm not really willing to go into its proof. It will just take up some time for me to first of all think in a procedural way, or some like something to show how to show it, and it will just become complex unnecessarily. Yeah, so basically the answer here is this part, the maximum of x plus m minus 1 by m and mx minus mn. This is the least number of operations you require, and it is always possible to do it in this many operations. If you don't feel very sure about it, if you don't feel very sure about it, try to think of try to think of many test cases. Just try to create a test case in which this might fail, and while trying this out you will start feeling that you will start feeling that you will always be able to make up in this many moves. Okay, so should we move on to the next problem? Is it clear? Let's look at the code also. First of all, taking the inputs. While taking inputs, I calculated the maximum element, minimum element, and the sum of the array. We use the word x there. I use the word here req required number of operations, the required number of sub operations. This is nothing but mx into n minus sum. You take mx into n minus sum. If you just try to write up this thing in short, it can be written as mx into mn minus 1, because every time you're just adding mx minus ai, so eventually you are just adding mx n times, and in the minus part you're just having a0 a1 all the elements included, so this is nothing but sum. Fine, then the answer would be at least these many operations, the number of sub operations divided by operations C division. If all the elements are equal, okay, so let's say if all elements are equal, all elements are 3. The first element is 3, second is 3, fourth, third is 3. The mx here is 3. 3 into 3, it is 9. The mx into 9 part, mx into n part, and all the elements are, the sum of all elements is also 9. So 9 minus 9 is 0. You don't really require any sub operations, which is correct. And here I'm just storing the maximum of this thing and this thing in the answer, and just print it. Simple. Is this clear? Should we move on to the next problem? Okay, great. Let's move on to the next problem. We are being given a permutation of n. Consider the subarray A equal to the like the prefix of the array, and we have to perform like we can perform the operation possibly 0 number of times, where we select 3 indices j, k, and l, such that j is coming first, then k, then l is coming, and ak is the smallest element, and we just delete that element from the array and concatenate the remaining part. In case you want to perform more operations, you will perform on the updated array. And we have to find the number of distinct arrays A can be from A which can be generated. Since the answer might be very huge, print it modulo this part. So the problem says that we are being given an a permutation of n. I guess we are being given the permutation also. Yeah, we are being given an array of size n, which is nothing but a permutation of n. What is a permutation of n? This is an array from 1 to n being permuted. So something like 213 is a permutation of length 3 because it contains all the elements from 1 to 3 exactly once. Fine. Now in this array, let's say we are being given the array as 4132. 4132. What we have to do is for every prefix, basically like this. 4 is a prefix, 41 is a prefix, 413 is a prefix, 4132 is a prefix. We have to tell how many arrays can we generate from these after applying some operations on these. And what we do in an operation? In one operation, we choose 3 indices. Let's say the array is 1413. Then we will choose 3 indices. Let's say we choose these 3, and the middle one should be smaller than both of them, both of the elements on the left and right, smaller. We can just erase this element and the array will become 4 3. The element would be just erased, and from the updated array which we would have, we can apply more operations on this as well. So whatever operations we apply on this subarray, like from this we can apply an operation and the array will become 4 3. It won't really affect what we have in the other prefix. This is just a clarification, though I think you would have already noticed this part. So what our aim is, we can apply this kind of an operation on any of the prefixes as many times as we want, and we have to tell how many distinct arrays can I generate from this array, from this array, from this array. You have to tell for all of these one by one. So if we see the example 4132, if we see the example 4132, if you have the array as 4, you can have only one array, that is 4. If you had the array as 41, you can generate only one array, that is 41. No, this is not a DP problem. If you had the array as 413, it can be like one of the arrays you can have is 413, and the other array you can have is 43. You can erase the one in between. And another array you can have 4132. Here also you will have only these two, 4132 or 432. You can erase that one part. So the only observation you required here is, let's say if the array was something like 4123, consider this thing. You can remove this one because it has one larger element on left and one larger element on right. You can remove this 2 also because it also has one element on the left and one element on the right, which is larger than this. So in a nutshell, there can be two different arrays, like there are two different choices for this element, whether you have it or not. The same thing for this, whether you have it or not. So two choices for this, two choices for this. You can have 4 combinations, whether keep 4 and 1 and 2 both, don't keep any of them, keep only one of them. For that you have two things, है ना? So the thing is, you have something like 4123 where you keep both 1 and 2. You have 423 where you don't have one. You have 413 where you don't, like where you just remove 2, and you have 43 as the array which can be generated where you remove 1 and 2 both, right? We cannot remove 4 because we don't have any element on the left which is larger than 4. We can't remove 3 because we don't have any element on the right which is larger than 3. So the observation here, like from this observation, we can conclude that if you're talking about a prefix of length I, basically all the elements from index 1 till I or 0 to I in zero-based indexing, just you need to know about the count of those elements which have a larger element on the left and a larger element on right also. How can 413 come? Okay, 413 can come because you can choose this 4, you can choose the 2, you can choose the 3. for any element which has a larger element on the left and a larger element on the right, you can just choose those three elements and get this element removed. So you always have two choices for this. Similarly, for this guy, you have two choices. So at last, if you have four number of such elements which have one element larger on left and one element at least one element larger on left and right, you will have 2 raised to the power 4 number of arrays which can be reached. And now the problem is asking you nothing but just print 2 raised to the power 4. Like you can just pre-calculate 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, and so on till 2 raised to the power n, because you will never require more than that. Like in modded form, like 2 raised to the power n mod like this. So you can just create an array like p2 I. You can just create an array like this, p2I with name p2, where on the ith index you have 2 raised to the power I mod n stored. Because the someone asked, because the previous prefix answer will also include in the prefix, how can we can use the prefix max and suffix max? No, you don't need prefix max and suffix max. Yeah, you don't need prefix max and suffix max. It won't really help much. One left shift and mod will not work here. Yeah. Someone might say that, hey, I can just say mod it, like left shift it by n and then take the mod. So the problem is the n might be very huge here. N might be equal to as large as 1e5. You cannot really left shift something with 1e5 value, right? Because uh, you can't really left shift it that much. What it does is just left shift the bit by one value. How will you store this? You know, you can't really do this thing. Oh yeah, some people might be a little bit confused that how did I just notice this thing very quickly, that you can create this kind of an array. So initially when I saw this thing for the first time, it didn't really come to my mind in an instant. It took me a while. But as you practice, you will just get more and more comfortable with this kind of thing. It is very standard. It is very standard. Okay. So now we have realized that for a prefix of length I, what you want to know is the number of elements. What you want to know is the number of elements which have an element greater than them on both the left and the right side within this prefix. If you have something like um, 4, 1, 2, 3 in this array, if you are talking about the prefix 4, 1, 2, even though 2 has an element greater than it on the right side, but it is not having it right now in the prefix. So only one is the one is the only element here which has an element greater than it on the left and right side, both the sides. So we have to take care of that thing. Now what we can do, now the problem is kind of solved. It is just simple thing left now. Just traverse from left to right. And initially what you can do is for every element in the array, just find out the next greater element on the left and the next greater element on the right, like the index of those elements. So while traversing from left to right, let's say if on the fourth index, the element says that the next greater element on the right is 8. Oh yeah. You should have done the problem of finding next greater element. This is a standard problem. This is a standard problem done using stacks. Done using stacks. Or you might have heard something like monotonic queue or monotonic stack. I think monotonic stack keyword is being used for this problem. Just search, if you have not done the problem, just search next greater element. on it, you will get a lead code problem or GFG problem. Attempt those problems, try it, you will learn it, like you will learn something from it, and apply it. And like this, it is applied to different problems a lot of times. So here we will find the next greater element for every element on the left and on the right. Now, like first traversal is just to find it out. The next time you traverse over this array, like the array you have, you traverse over it from left to right. If on the fourth index, the element says that the element greater than or on the right side is on index 8, and the one than there's on the left side is at index 1, you can just mark this index. You can just mark this index that, hey, whenever my prefix length become equal to 8, that count I needed, the count should be incremented by 1. Let's say there is some more element on index 5, which says that the next greater element is on index 8. So here you want that when you come to index 8, it should be incremented by 2, right? So what we can do is just create a count array, and whatever index on the right side is greater than the current index, just increment it once. After that, you can just, let's say the array is something like 4, 1, 2, 3. For the index 4, there is no element greater than it on the left or right. Let's write it left and right. On left, there is no greater element. On right, there is no greater element. Let's write n for it. On left, for this one, the greater element than it is on index 0. On right, it is at index 2. For 2, it is at index 0 and 3. For 3, it is on index 0 and 4. Like no element greater than it on the right. So now what you want is you should have the counter when once you have the prefix of length 1, it should do nothing. Once you have the prefix of length 2, this this 1 would be having an element greater than it on the left and right once you have the prefix of length 2, right? So you just say that in the count array, go to the index 2 and increment it by 1. Now talking about the element on index 2, you see that it has an element greater than it on the left. It has an element greater than it on the right at index 3. So you just go to the index 3 in the count array and go and increment it by 1. It tells you that when you will have a prefix of length 4, like coming till index 3, so length 4, you will have one more element incremented, one more element added, such that which can be removed. Now just take the prefix sum of this. Now just take the prefix sum. So it will say that for a length 1, you don't have any such element. For the length, sorry, for length 1, you don't have any such element. For length 2, you have one element. Sorry, you again don't have any element. For length 3, you have one element. For length 4, you have one more element. So two elements now. Now in my code, instead of creating a prefix sum, another array for prefix sum, I just stored the prefix sum array within CNT array itself. You should be comfortable with it if you are attempting this problem. Like if you are coming till this problem, you should already know about prefix sums also. So one of the prerequisites was this problem, and another one is prefix sums array. You should know about this thing also. So once we have just calculated this count array in which CNTI is, or maybe call it as pre for now. In code, I have just done it in CNT itself. This pre-I is telling the number of elements which have at least one element greater on left and at least one on right, at least one on right. Yeah, this is just telling about this. In the prefix till index I. So this is what we have in pre. Now, what will be my answer for a prefix of a prefix till index I? What would be my answer? My answer would be nothing but 2 raised the power pre I mod, like whatever mod value we have. It is something like 998, but something big. And this is nothing like we have stored this thing in P2 of pre I. Like P2 of I is nothing but 2 raised to the power I mod. So P2 of pre I will give me this thing. So I just have to print this. And that's it. By the way, remember one thing. If there had been some element which has a larger element on the right, let's say if the whole array was till here, it was 715 also, then this 4 has an element on the right larger than it. It does have it, but it doesn't have any element larger than it on the left. So we should not increment the count for index 4. We should not do it because 4 can never be one of the elements which has one element greater than it on both left and right. So we should just skip it in that case. So now I think that if you just do all the steps, the problem is easy now. And here is the code. First of all, I took the inputs. Can you please again explain why answer is 2 raised the power prefix? Okay. Let me take up an example for it. That same example. 4123. Okay. Pankaj, please tell me the number of what should be pre of 3 here right now? What should be pre of 3 here right now? It is the number of elements which have an element, at least one element greater on the left and right. Yeah. So here I have pre 3 equal to 2. Now what I can do, what this tool is telling me is these elements have at least one element on left and right greater than them. So if I want, I can apply an operation on this element, the element greater than it on the left and on the right, and it would remove this element. So I can have all the arrays I can have in which it is included. I can have all those arrays also in which it is not included. Everything except the same. Similarly for this case, either I include it or I don't include it. So I have like include or don't include or don't include. I have these two cases for this guy, two cases for this guy. And if you have done like some sort of even some school level PNC, you might be getting already some intuition that just multiply it. You know? And maybe if there was something like 5 here also, in that case, for 3 also you will have two cases, in or out. You know? You can generate then 8 uh, arrays. 4 1 2 3 5, 4 1 2 5, 4 1 3 5, 4 1 5, 4 2 3 5, and similarly like 8 cases. Simple. It is looking like binary already. You know? So yeah, this is how we can generate 2 raised to the power cases. And we had to give the answer with modded with this 998244. I always forget this number for some reason. So that's why. Um, and obviously, I cannot really store 2 raised to the power 100 in any place. So we are just storing it with mod. Finding it is not hard, it is something simple. If you have done it already, if you have never done it before, you might feel it a little confusing for the first, but it is very useful. It is quite standard, being used at a lot of places. You will get used to it. First of all, taking the inputs, then using a stack, like instead of using a real stack, I used a vector and use the pushback and pop back uh, and back method to act it like a stack, and just create found the next greater element on left and right like this. After that, I just traverse the array and marked down the elements, um, the indices at which I would get increase in the number of such elements which have element on left and right both sides greater than it. After that, I just calculated its prefix sum. Instead of using a new array, I just stored it in the same array. After that, I just created an array P2 in which I stored the 2 raised to the power I at index I. And like you can just pre-calculate it also out of the test cases, but it doesn't matter in this problem since n is bounded. The sum of n is bounded. So you can create it here also. And after that, for every prefix sum, I'm just going to print P2 CNTI. So yeah, it was not as simple as the previous problems, but it was at least doable, at least solvable, I guess. Right? So did you understand this problem? Okay, great. So let's move on to the next problem then. This is score sum. This is also an observational problem. Like this one is simpler than the previous one. It just involves some maths. We have been told that if we have an array of length m, let the array be b, then the function fb will be giving me this. Like there is an expression given to us. We will see this expression. We have to say we have been given an array a, and we have to tell the sum of fs for all the non-empty subsequences of s, subsequences s of a. Since the sum might be too huge, print it modulo something. So the problem looks complicated in the first go, but it is not complicated. It is easy. It just requires some observations. First of all, talking about what is this f of b. This f of b is nothing but the sum of I equal to 1 till m minus 1 minus 1 raised to the power I plus 1 and absolute difference of bi with bi plus 1 raised to the power 7. Yeah, it looks complicated. And I think that they have intentionally done this so that it looks complicated. The guy feels that whether I would be able to solve the problem or not. But if you notice this part, bi, like just to make it a little simple, look simple, let's create a function which takes two input and it returns absolute difference of a minus b power 7, just to make the thing look cleaner. So instead of writing this complex thing, I can just say this is nothing but f of bi and bi plus 1, yes. Yeah, bi plus 1. Okay, it looks a little simple. Now, to make the expression look more simple to us, let's open this summation thing. So f of b is nothing but f of b0 b1. Right now for I equal to 1, sorry, I equal to 1, it would be b1 and b2. And for I equal to 1, I plus 1 is going to be 2. Minus 1 raised to the power 2 is just 1. When I would be equal to 2, then I plus 1 is 3. Minus 1 raised to the power 3 is minus 1. So minus b2, b3. And I think now it is simple to see that we are just having this thing. You have already done, anyone watching the video, I hope everyone would have already done some school level math. So uh, opening up the summation is just going to give me this thing, right? Now just imagine if you have the array as 1, 2, 3, 4, 5. Why am I taking so simple array? Because you want to just have some observations. For observations, we are having a very simple test case where we will try to find some pattern. Let's say this is the array B, or this is the array A which we have. One of its subsequence would be 2, 3, 4. Let's say 2, 3, 4. You talk about 2, 3, 4 as a subsequence. Right? We have to talk about all the subsequences. We have to find the sum of FB for all the subsequences FS for all subsequences of the array. So if 2, 3, 4 is a subsequence, here the f of this array would be f of 2 comma 3 minus f of 3 comma 4. Right? You will have a subsequence. If you have a subsequence 2, 3, 4, you will have a subsequence 1, 2, 3, 4 also. Right? Here in the first subsequence you don't have one, but you will have a subsequence where you have one also. In that subsequence, you will have f of 1, 2 minus f of 2, 3 plus f of 3, 4. Hey, bro, what is this happening? Everything I had here in this subsequence has been neutralized by this. Everything has got cut down because eventually I have to sum up both of these as well. So anything which remains is just f1 comma 2. Let's try to think of some other subsequence. What about 4, 5? If I take up a subsequence 4, 5, I will have a subsequence 1, 4, 5 also. In 4, 5, f of this thing was just f4 comma 5. Here in f1, 4, 5, I will have f of 1 comma 4 minus f of 4, 5. Basically, it is signaling us that if any subsequence, like you talk about any subsequence which doesn't consist 1, the subsequence which consists 1, like if you talk about any subsequence s0, s1, s2, s3, as these are the elements of the subsequence, there will definitely exist a subsequence. If s0 is not equal to 1, then there will be a subsequence s0, s1, s2, s3, and whatever this gives you, it will just cancel out this part of it. So all you will have remaining is the so the answer of subsequences is number of subsequences into fa0 a1. Not exactly this part, but yeah, you're getting on the correct path. If I have a subsequence like 1, 2, 3, if you talk about a subsequence 1, 2, 3, in reply of this, there is a subsequence 2, 3. So basically, you just add one or remove one. The other subsequence, which you just toggle this one, and the other subsequence will cut down everything. So what will remain is 1 along with the first element of the subsequence which was taken. So here f of 1, 2. How many times will this come? All the subsequences which contains 2. All the subsequences which contains, or maybe you can say the number of subsequences which contains 1 and 2. All these subsequences will have f1, 2, right? Or not just one contains 1 and 2. It contains 1 and then 2. The first element of the subsequence should be 1 and the next element should be 2. How many subsequences will be there? You are having 1, 2, and then you are having some n minus 2 elements. You don't care which element you take, which element you don't take. Basically, you will have 2 raised to the power n minus 2 combinations of these n by 2 elements, n minus 2 elements. So there are 2 into 2 raised to the power n minus 2 subsequences in which 1 and then 2 comes, which starts with 1 comma 2. So f of 1 comma 2 is 2 raised to the power n minus 2. Similarly, check for the subsequences which have 1, 3 as the starting elements, and whatever it has afterwards, like it doesn't matter because it would just get cancelled out eventually. There are n minus 3 elements, right? If the whole array had n elements, then after 1 and 3, because you have not taken 2, after these there are n minus 3 elements. So you will have n 2 raised to the power n minus 3 f of 1 comma 3, and just generalizing it, if you have some if you talk about some I here, f of 1 comma I, the element on the I basically, f of 1 comma ai, how many subsequences will be there for the index I? How, it depends upon the number of elements left after it. So if you are having this I in zero based index array, you will have n minus I minus 1 number of elements after it. So 2 raised to the power n minus I minus 1. Yeah, absolutely correct. So we just have to find out the sum of 2 raised to the power n minus I minus 1 f of 1 ai. Now this f of like this function which just gives us this complex looking thing, absolute difference of both elements power 7, is we can say that it is working in big of 1 because it is just having a loop of 7 size. And we can just calculate this and store it in something like p2, where p2i gives us 2 raised to the power n minus I minus 1 mod you have p2i. So basically what you do is just say p2i into f of sorry, it didn't have 1, it had a0 there. Like in the example I took, a0 was equal to 1, but in the formula you will say a0. Yeah, so we will have a0 into ai, and just take the mod again because you're multiplying. Take care of overflows, because if you just have this isn't, so overflow ho sakta hai. That's why just typecast it to a long, or maybe multiply it with 1ll, because 1ll is also long to take care of overflows. And what you get here is like you have to take the sum of all these for in a for loop. So just run up a for loop for int I goes from 0 to n minus 1, and you have to just sum it up into answer. You have to maintain a variable answer equal to 0 initially. So let's say this thing to be equal to cur, you will just say answer equal to answer plus cur mod mod, and at last print answer. That's it. So yeah, the problem involves some mathematics. So for those who have not done enough practice in this kind of thing, you might feel it a little confusing. But overall, if you have done this, the problem is just easy peasy. You just had to make one this simple observation. The code is like this. We first of all take the inputs, then create this uh, power array. Here I named it as PW. You can name it as P2 also. Like I have seen some grandmasters naming like P5 for the array for power 5, P10 for the array of power 10. So you like, this might be a convention. I don't know what it. Just name it anything you want. And for the function, I just created it in the lambda expression, which takes two expressions a and b, and returns absolute of a minus b multiplied to itself 7 times and taken mod every time. And for the answer, just initialize it with 0. Every time I'm storing current, the expression into a variable current, and then adding it to answer, taking the mod, and then just printing the answer. So let's like, did you understand this? What is the benefit of using lambda representation? One major benefit I feel is that, like, first of all, this is bad, but it looks cool. The reason is bad for using it, but it looks cool, so I like to use it for this reason. And the next thing is, if I, let's say, write it here, int a and b, and here I want to use this mod thing. I want to use this mod. So I would have to pass it. I would have to pass it as a parameter, even though it is not really going to change. or I have to declare it globally. Just imagine if I had to use a vector also. If I had to use some value of this array, this scope thing. This is also a benefit. And one more thing is, if I'm writing the code, if I have to write this function, I don't have to go up and write it there and then come back. Okay, so let's move on to the next problem. Now for this problem, okay, this one is also simple, like simple in comparison to at what level it is coming. It was the 9th problem of the contest, so in comparison to that, it is simple. We have been given a binary string. We have been given a string which of zeros and ones, a binary string, and let's say f of x denotes the longest non-decreasing subsequence of the binary string x. Basically, you give a string as input and it returns you the length of longest non-decreasing binary string, right? So we have like this is a function which we are being told that let fx be denoting this thing. We have been given a string and we have to partition it into two disjoint non-empty subsequences s1 and s2 such that the minimum of both the subsequences, the function, like the both the subsequences being passed into function is as large as possible. So we are being given a binary string something something. We have to partition it into two subsequences, disjoint subsequences, so no element should come in both of them, and it should be non-empty. So let's take an example. If we have 101, if we have the string as 101, we can partition it into two parts. One of the parts having 11, this 11, and the other part having only this one, only this 0. Here the if you pass this into the function, the longest non-decreasing subsequence is of length 2, this whole thing, and in this case it is of length 1, and the minimum of this is this guy. You want this value to be like, this would be your answer, and you want to have it as large as possible. So for this problem, I just had one intuition, or maybe just some idea which I wanted to try, that let me have the two partitions as let's say partition 0, partition 1. In the partition 0, all the zeros I have in the array, I will just put them up here. Let's see if we have an example. No, we don't have an example. Maybe I have something like 0 0, or let me use, I wrote it down on the notebook. Yeah, 0 1 0 1 1 0 1 1 1 0, something like this. So here we have 4 zeros. Just place them in the first partition. All the ones you have, just place them in the other partition. Here I have 6 ones. So in this case, what we are doing is we are utilizing each and every character to be a part of the longest non-decreasing subsequence, right? Here f of p0 will be 4 and f of p1 will be 6. So at the very least, you have understood that my answer will at least be 4. My answer will at least be the minimum of count of 0. Let me denote it with f. Yeah, basically just use count for now. So my answer would be at least the minimum of CNT1 and CNT0, right? Now what I did, like now what I got in my mind is, I can just put up the elements like this initially. After that, this one is having a smaller length. You know? can I try to make it larger? Can I try to think of a case where, can I try to think of a partition in which this guy has more elements in the longest non-decreasing subsequence? So maybe one thing I can do is take some ones from this partition and like the one of the ones and push it here, push it here. So just imagine if the string was like this. In that case, right now what I had is, um, sorry, yeah, right now what I had is the first zero, like the partition is like this. All the zeros are in the zero and all the ones are in the partition one, P1. Take one of the ones from the end and push it into the partition 0 when I had the count of 0 to be less. In this way, you will have the number of elements in P0 increased. Since you have taken the one from the end, it is likely gonna be increasing the length of the longest non-decreasing longest non-decreasing subsequence in P0. So F0, like FP0 will become 5 and FP1 also will also become 5, right? Now again, just say there, here just say answer is equal to max of answer and minimum of both these things, both the f of P0 and f of P1, right? Like this, whatever the maximum is, just push it. I knew initially that P0 was the problem. Then I said that, hey, just try this all at every place. Take this element off and place it here. So now f of P0 will become 6 and it will become 4. So yeah, it is not really benefiting me now because f of P1 has got smaller. But I just did run up a whole for loop, which you can even break if you want at some place. So the main idea from this is initially just push up all the zeros into one of the partition and push up all of the ones in one of the partitions. Now, if the number of if the partition 0 is having less elements than partition 1, then start taking ones from the end of the partition, like one from end of the string, pop them out from partition 1 and push them in the partition 0. Do this for the whole time. Basically, even if you try out just brute force time, basically. I know that there are many redundant stuff here we can ignore, but I just said that uh, remove start removing all the ones from the end of the partition 1 and push them into P0 until you have pushed up everything into P0. And if you want, you can stop it somewhere. But we cannot push more than 3 ones. Okay, so you have a doubt that, yeah, okay, that case when 0 comes. I did talk about, sorry, not talked about it yet, but in my notebook, I had written case 0, 1, just remove a 0 from here and add it here. If you remember, I wrote it initially. 0, 1, 0, 1, 1, 0, 1, 1, 0, 0. Sorry, 0, 1, 1, 1, 0. This case. So, I was just checking what will happen in case if adding this one is also costing me something. Can this case happen? I just wanted to check, and yeah, it can happen. I might have P0 with 4 zeros and P1 with 6 ones. Then for removing this one from, sorry, for removing the one from P1 and adding it to P0, if I remove it from here and add it here, it would come like this. So this 0 which I have, having it or not having it is just useless for me. Like it's not having any contribution now, right? It is not going to have any contribution for me now. So I just said that, hey, pop it also. Just pop it. Don't just forget about it. Forget about the zero. Because in the worst case, what will happen is I won't get anything better. I'm just checking if I can get anything better or not. And then I said that, hey, pop out one more. I'm sorry, it won't be removed from here. I just said that, hey, pop out one more and push it again and just do this. So basically, from here on, you can try to think of more cases if you want. In my case, what happened is the intuition which I got, I just tried to check if it is working or not, and it did work. I didn't do a lot of casework because it just went on correct in one go. In case if I had P0 greater than P1, in that case, what I did is I started popping out zeros from the start of P0 and pushed them at the start of P1. Yeah, we will take P0. Yeah, in case if P0 is greater than P1, we will take out zeros from start of the string which are included in P0 right now and add them to P1. In case if P0 and P1 are already equal, we can't really do anything. We have already got our answer to be both of them would be equal. So just say f of P0, right? Like this. Like from here on, the problem is very doable. So what we do here is just take the string as input first, and then instead of using the word cnt, I just use the word f. Here this f of 0 would be telling me nothing but f of p0. Basically, this would be telling me about that part only. So initially, I'm just adding up all the zeros to f0 and all the ones to f1. Yeah, like you are the only guy in the meet right now, and I think it's quite good for you. You just understood till the ninth problem of the contest. By the way, what's the rating right now? That's quite a lot of upsolving for this problem, I guess. Okay, see here. I'm just very low as of now. Okay, no problem. Just want to make sure I started recording. Yeah, it's recording. Just imagine if I had forgot to start the recording. Uh, I'm having a vector of int f where f of 0 is just telling me about uh, the longest non-decreasing subsequence of binary string of the partition 0. Okay. Here initially my answer is the minimum of f0 and f1. Here this f0 is like nothing but this part which we had been writing like this. In the code I wrote it like this. Okay. In case if f0 is less than f1, then I'm just traversing from the end of the string. In case if I get a 1, right now, if the f1 is greater than f0, what I'm doing is I'm traversing from the end of the string, and if I get a 1, if I get a 1 at some place, I am removing it from the partition 1. So f of 1 should reduce, and I would be adding it to this. So f of 0 should increase, right? In case if I get 0, in case if I get a 0 at this place, you see that if I include some 1 at some place, then this 0 would not be having any contribution. So it's quite equivalent to removing the 0 from the partition 0. So in this case, we will have f0 being decreased. Yeah. And similarly, for the case if f of 0 was greater than f of 1, we would just traverse over the string from left to right and do the exact opposite. For 0, we will uh, decrease f0 and increase f1, and for 1 we will just decrease f1, and if at the end we will just print answer. Okay, so I hope you got this problem also. So for the people who have been watching on YouTube, please like the video if the editorial helped you out, and you can consider subscribing to the channel also. And please give your valuable feedback in the comment section. And bye bye.